Welcome to Chapter 9, Section 6, called Similarity Transformations. This is for Integrated Math 2, or IM2. So a couple of things just before we get started that you'll see on your screen. The first thing you should see is a due date. I don't see it on my teacher preview here, but you'll see it on your student side. Unlimited attempts, that's always true for homework, tests, and quizzes. Number of questions just tells us how many questions are on this assignment. Grading policy is best score, so whichever attempt is the best one is one you keep. And partial credit is enabled, so if you answer 1 or 2 questions correctly, you get credit for that one question, or however many you answer correctly. Down here it says once you start your homework, you must finish it before you can work on anything else. What that means is once I click start, down here in the bottom right corner, I will see a submit assignment button. I need to make sure that I click that submit assignment button. That's how I finish my assignment. So when I'm ready to leave the screen, whether or not I finished the entire assignment, I'm going to click submit assignment. Because what it means by not letting you work on any other assignments is that Alex is going to lock out your account. So it's going to lock all other assignments, it's going to lock the resources, it's going to lock the gradebook. So really, everything kind of gets locked out until we click submit assignment. So it's very, very important, good habit, always get into clicking that button. So on the side here we have explanation, example, and message center. Explanation is going to tell you you're going to lose your question attempt, because it's going to give you the answer to this question. It's going to show you how to do it. Example will show you kind of what to do here. So we have 2 figures again, and it's showing us that we're going to try to move one over to the other to see if they are in fact similar. And then you can open this again, if you want to look at another example. You can also message your teacher directly from the screen. It attaches a picture so we know where to come help you. All right, so this is in each part. Use the tool to move the solid triangle exactly onto the dashed triangle. If this is not possible, click on not possible. So I want to move the solid figure onto the dashed figure. So first, this tool lets me move it. It's a translation tool. This is my rotation tool, so I can spin it around. This is my dilation tool, so I can make it bigger or smaller. This is my reflection tool, so I can flip back and forth. I can also do up to down, so it's vertical and horizontal. I have to choose which one. So I'm going to move this guy over, and it does look like I want to spin it, maybe like this, but then I also want to flip it around a little bit. Come on. Just a little bit, and then it looks like I do want to dilate it just a bit. I'm going to move it back up, and it snapped right on there. So that means it's possible. That is the answer right there. As long as I can do that, I just leave it alone. Now I'm going to come over here and I'm going to work on this next one. So let's see. If I spin this guy around, this, and then I'm going to dilate it. So it partially works because I can kind of get this to fit down here. And I can dilate it just a little bit more, I think. Why isn't it letting me do it? There we go. I think that's actually a little too big, because now it goes outside of the triangle. But there's no way I can get these two to work together. They are different types of triangles. They are not similar. So I just click not possible, and that's the answer. And so I click check. So this one's very much so you need to be able to be on Alex and kind of be manipulating these pieces, but you're just trying to get one to fit right on top of the other using these similarity transformations. The next one, we're going to do something very similar to it. But keep in mind, when we move the triangle, so we're going to move the solid triangle onto the dashed one. When I do this, if you notice, it doesn't take any of the numbers or the letters. So I have to very much so keep it in mind how I'm turning this in order to do that. So I'm going to really quick, that's that guy. I'm gonna go like this. I'm gonna put it over here just so that I can see it happening, so I can kind of show you the visual when it's moving these pieces. A little bit bigger. All right. So I'm gonna lasso this guy. I'm gonna go copy paste. So now it gives me a copy of this one that I can kind of manipulate here. And I know I want to turn it, definitely, because that's I can see that it's laying down. I'm also, I don't know if it'll let me flip it on this one. Oh, it's not very nice. Okay, so I can see that I've got it flipped in the right direction. Now if I lassoed that guy again, although now I'm going to be losing some of my pieces because I don't have, here, before I do that, let's see, I'm going to write my letters down. So I have Z and X and Y. All right, now let's go ahead and lasso it. Boom, and I'm going to paste. All right. So now if I move this guy up, it's not quite perfect yet, but it's getting a little closer. I just need to dilate it. Need to make it a little bit bigger. And I know I didn't draw the lines quite perfect on there when I did that. So it's not going to be perfect in this situation, but I can definitely see where these land. So Z, and I can go ahead and do that on this guy here. So rotate it down and then flip it that way. And dilate it just a little bit. Boom, like that. So we need to do that step because that's part of what Alex is expecting here. But now we need to make sure that we're looking at the pieces here. So complete the congruence. So X is going to be congruent to this bottom one G. I know it's covering G up, but it's right on top of G there. And then Y is over here by I, and Z is on H. So that's the only problem with this one, is that you have to visually make sure you're kind of following that, how you're rotating and turning it, or flipping it if you're doing the reflection, which we did have to do the reflection. So we just want to make sure that we're following those angles as we go. All right, so find the ratio, the following ratios. Write your answers as fractions. So we have GI, which is 15, over XY, which is 12. So it did say simplest form. So we need to make sure that we simplify this. This can divide by 3. 15 divided by 3 is 5. Why did I do that? 5, and 12 divided by 3 is 4. So now I have HI, which is 45, and I have YZ, which is 36. So I'm going to simplify those as well. Let's see, what do those both divide by? They both divide by 9. So 45 divided by 9 is 5, and 36 divided by 9 is 4. Look at that, the ratios are the same. We want these ratios to be the same. If they're not the same, something has gone awry here. It means that the triangles aren't similar. So now we have 40 over, because it was GH over XZ, which is 32, and both of these can divide by 8. So 40 divided by 8 is 5, and 32 divided by 8 is 4. So the ratios are the same. So triangle XYZ and GIH are similar because the angles are congruent. All three angles are congruent because remember, that doesn't change when I'm doing these similarities. I don't know if it'll let me copy this guy again. Let's see if it will. Ooh, it did let me do it. Oh, no, it didn't let me do it. Darn it, it won't let me copy it again. But if I were to dilate this one and make it bigger, the angles don't change. We've kind of tested that before on other pieces, and I don't necessarily need. It's just arguing its butt off here. Okay, brand new. So I'm going to make a triangle really quick just to show you what I'm talking about. And then I'll lasso that guy because it's not going to argue with me on that one. So now I have two triangles. They're exactly the same. These are congruent triangles if I were to draw them, separately, which we dealt with for a while. But I can also dilate this, can make it larger or smaller, and that doesn't change the angle measures. Each one, boom, 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 all the angles fit. And I can also make it larger, same thing. Angle fits, that bottom angle fits right there, and then the right bottom angle fits. So all of the angles stay the same by dilating it. It doesn't change that idea. But the side lengths do change. They are going to be proportional to each other. So we have 5/4 for the ratio of the side lengths. So we're going to go ahead. Sorry, big old yawn there. I don't know why I yawned. But... All right. So that was section 6. I will see you in section 7.